This is from the Sean's outline on integration, right? Which is I posted on Blackboard, and this is number 69. There's outlines for this for every math course you'll take. So for your computer scientist, for linear algebra, you want to get the Sean's linear algebra and the Sean's advanced linear algebra. The advanced will have all the proofs in it that you're going to have to do. Okay? So good idea to get that before that class starts. This is 69. This is an easier one. And I've gone through my checklist. So what does that mean? It means I'm kind of thinking it's got to be an inverse trig, because everything else I've tried. Everything else I've tried, so it's got to be an inverse trig. And obviously, I'm looking at an arcsine here, right? So I'm reminding myself that if I have the integral of 1 over square root of 1 minus u squared du, I get the arcsine of u, right? Right? Everybody okay there? Yeah. Mike, okay? Mike, okay? So I've tried everything on my list, right? I'm up to whatever, it doesn't matter. The last thing is on my list is inverse trigs, right? So, of course, I tried, before I went here, I tried a u sub, right? Because there's a clear inside, right? And if I look at this inside, I get a du of what? Negative 12 minus 2x, right? And sure, I can get the negative 12 by multiplying by negative 12, but I can't add in an x, right? I can't add in a variable. So I'm hoping that this will complete the square, right? This will be something that I can complete the square with. So I'm going to, right? So this failed, right? I can't introduce a variable inside of an integral because it is, right? It's dependent upon x. So I can't move an x in or out of the integral. I can move a constant in, a coefficient in, but I can't move a variable. So like if I looked at this again and I said, oh, I need an x squared, right? Sorry, I need a negative 2x. All right, let me multiply the top by negative 2x. That means I also have to divide by a negative 2x. And you can see it's already way more complicated than before. And it's not going to fit the arcsine version anymore, right? So I see it fails. And it's good to fail. When you're practicing at home and you fail on a couple things, it's good. And you can send it to me and say, hey, why didn't this work? Right? So I'm going to try and complete the square. I don't know if it's going to work, right? Michael, you with me? So I've got a 28 minus 12x minus x squared. Since the beginning of time, we've always taught you to factor with a leading positive coefficient. So I want to get this set up so I can have a positive leading coefficient. So I'm going to factor out the negative 1. Say it again. Yes. 28 here, right? Sorry, thank you. Yep. So I factor out that positive leading, I factor out so I get a positive leading coefficient of x squared now. That's what I want, right? So now I find that the coefficient of x, which is 12, half of that is what? 6, square it. I get a 36, but that's actually what kind of 36? A negative, so I want to cancel it with a 36 on the outside. So now I have a 64 minus, and remember this is now a perfect square, x plus half of 6, sorry, x plus 6 quantity squared. That's good. That still looks like my 1 minus u squared. So now I have the integral of 1 over the square root of 64 minus x plus 6 quantity squared dx. But I don't want the 64 there. I want a 1 there. So I'm going to divide by a 64 inside of the square root, right? Dividing by a 64 inside of the square root, but outside that becomes what number? 8, right? Square root of 64? Yes? Is that right? Okay. I'm starting to doubt myself. So tricky there in that 64 is inside of the square root. So I'm dividing by 64 inside of the square root. But if I'm dividing inside, I have to divide outside too, right? So I'm dividing by 8 on the outside. Is that okay? So now I have 1/8 times the integral of 1 over the square root of 1 minus x plus 6 quantity over 8, all over 8 dx. Right? That's 64 is inside the radical, but now I want it inside the radical and inside the square, right? So you can see I have a u now of x plus 6 over 8, and so du is 1 over 8 dx. I have that, right? So I have 1 over, the integral of 1 over the square root of 1 minus u squared du, and so that's arc sine of x plus 6 all over 8 plus c. How we doing? Mm-hmm. How we doing? We okay? What's the hard part? Is the calculus the difficult part? No.
Go over all the
Yeah, the checklist? Yep. How are we doing here with this problem? No, where's the issue? Yeah. So notice, remember what I want inside my radical. I want 1 minus u squared, right? So I don't have a 1 there, I have a 64 there. So I'm dividing by 64 everything inside the radical and dividing by the square root of 64 outside the radical. The square root of 64 is 8.
Everything else is divided by the square root because
Because it's inside the radical. That 64 is really a square root of 64, right? This is not on the quiz today, right? So you still have time to practice. You're supposed to be practicing. If you're practicing from home and you're having trouble, you're supposed to be communicating with me or Dr. Early. I don't think you're doing those things. You got to be practicing. All right, let me go over the checklist, okay? We know F prime, right? Right? First one, we just know it. We don't need to think about anything. We know the antiderivative. Second one is the power rule, right? Add 1 to the power, divide by the new power. Step 3, tricks. Level 3, there might be some tricks. Long divide, multiply by 1, right? Add 0. Long divide, divide and conquer. Level 4, our first U sub, right? U sub. U is a whole function. Du is the derivative dx. You'll have one like this on your quiz today. Level 5 is another U sub, but U is going to be the inside. It'll be an obvious inside. Level 6, it's another U sub, but U is going to be the downstairs. And the main thing you have to worry about there is that you're going to get an ln of the absolute value of U, right? Level 7 is a U sub, but there'll be leftover x's. right? Find a substitute for x. Level 8 to 11 are just inverse trigs. Make sure you practice. Right? 7 is what? Yeah. So I think we had done something like 2 minus x times the square root of 5 minus x or something like that, where I let u be the inside, right? Du is opposite of 1 dx. But then I have a leftover 2 minus x here, right? I have that leftover 2 minus x. And so obviously I can solve this for x and plug it in. I'm happy to finish that one if you want me to. Yep. So here's the problem. So clearly u is the inside, is on my checklist. I don't know if it's going to work, but I'm going to try it. And then du is just a negative 1 dx. Okay, that's good. I can get that negative to happen and cancel it. So I have negative integral. There's a 2 minus x left over. Notice that negative dx is du, and 5 minus x is u. So I've got the square root of u du there. Is that okay? I see my leftover x here, and I don't know if it's going to work, but I'm going to try it. I'm going to solve this for x. I get x equals 5 minus u, and I put that in for x. Well, I'm happy now because there's no more x's involved. I want to make sure, I don't know for sure it's going to work yet, but let's see, right? That looks like I have 2 minus 5 plus u. So it looks like I have u minus 3 square u to the 1/2. I like that because I know I can distribute and it's a power rule, right? So I distributed the negative and I distributed the u to the 1/2. Yep. Yeah, yeah, kind of. Divide and conquer I like better when you're thinking you're splitting a fraction into two fractions, but still this works. You're splitting an integral into two integrals. You okay? So the 3 is negative, right? So it becomes positive. Again, that's me doing arithmetic. I don't care how you do yours. You don't have to do it like mine. You probably won't. The arithmetic, the signs, the switching things around, you don't have to do it the way I do it. Just do what you know how to do. And double check yourself, right? So now I get, I have a 3u to the 1/2. I'm going to add 1 and divide by the new power. I have a minus u to the 3/2. I'm going to add 1, divide by the new power. And I'm going to add a constant c. I'm going to tell you today that that c is 0 on your quiz. I'm going to say, hey, let c be 0. Right? Don't do it a shift. Just have it right at the mother function, right? But now I'm just doing, I mean, it's not even algebra, it's arithmetic, really, right? But let me wait for you here. Get here for me, and then give me some kind of sign that you're here on line 7. Nice. Mike, almost? Okay. Nice. I can simplify a little bit, and I can see I need an LCD of a 5. And I'm trying to just have a nice clean rewrite here of 2 times 5 over 5 u to the 3/2 minus 2 over 5 u to the 5/2. And then I can see I could factor out the 2 over 5 and a u to the 3/2. So I got a nice version right? I had to put in u now, and I think I remember u is 5 minus x. Nice. Very cool. It looks like I just get an x, so I get 2x over 5 times... hold on. What happened to the 5/2? 3/2 times 2, u to the 3/2 times u to the 2/2 is u to the 5/2. Right? When you're multiplying like bases, you add exponents. Where? Yeah, so I'll show you again how I got my students that had a hard time factoring to get it, right? I'm gonna go back to here, okay? I'm gonna go back to here and notice that I have a 2/5 times a 5 times a u to the 3/2 minus a 2 over 5 times a u to the 3/2 times a u to the 2/2, right? And then I can see in green what can be factored out.